Okay, one of the other questions I got from you guys through email was for number 51. They give you a flywheel is a solid disc that rotates about an axis. So we'll say the solid disc, and this is the axis of rotation. And they tell us that it rotates perpendicular to the disc in the center. The flywheel provides a means for storing energy in the form of rotational kinetic energy and are being considered as a possible alternative to batteries in electric cars. And it tells us that the gasoline burned in a 300-mile trip in a typical mid-sized car produces 1.2 times 10 to the 9 joules of energy. How fast would a 13-kilogram wheel with a radius of 0.30 have to rotate to store this much energy? Give your answer in revolutions per minute. Alright, so we just kind of worked through this. They tell us that the flywheel is 13 kilograms. The radius is 0.30 meters. They tell us the amount of kinetic energy that it would need to produce is 1.2 times 10 to the 9 joules. So I will probably want to find the moment of inertia first. Moment of inertia for a solid disk is 1/2 mr squared. When we calculate that, we find that the moment of inertia is 0.585 kilograms meter squared. They give us the kinetic energy, so we're going to use our kinetic energy equation that says for circular motion that the kinetic energy is the moment of inertia times the angular velocity squared. They gave us the kinetic energy. We know the moment of inertia, and then what we want to find is the angular velocity. When we calculate our angular velocity, we find out that it's 64,051 radians per second. But they don't want it radians per second; they want it revolutions per minute. So we gotta convert radians per second to revolutions per minute. So we have our first conversion here. We do 6,451 times 1 revolution, which is 1 to 2 pi radians, and then we convert the seconds to minutes. Kind of multiply it through, and we get our answer is 60. Got a weird thing there. 611,644 revolutions per minute would need to be required to produce enough kinetic energy to be equivalent of 1.2 times 10 to the negative 9 joules. And that's it.